Hello, good afternoon. My name is Yaning Zhou. I work as a research manager at Technical University of Dresden. In Hexx, I'm leading the work package on novel radio access technologies towards 6G. And today I also represent my colleague in Hexx, and that is Henk Wymeersch from Germany, Aarno from University of Aarno, to give you an overview on our planned work on the novel 6G radio. So why do we need 6G radio design? First of all, this is a tradition. The evolution of every generation mobile network starts from air interface design. But of course, we cannot develop technology just for its own sake. We are looking at future innovative use cases such as holographic communications and telepresence, which may require extremely high data rate up to 1 terabit per second. Combine such extreme data rate with extremely accurate positioning and sensing. New capability and new opportunity will open. Another dimension here is that as we observe in the corona time that connectivity has become one of the fundamental building blocks in our society and economy. Therefore, 6G radio design must meet the demand in exponentially increasing capacity in the next 10 years. Considering climate change and sustainability, energy consumption will be one of the most important design considerations for 6G radio. From technical point of view, we also see two disruptive new factors. First is commercial exploitation of higher frequency from 100 GHz. The second is a convergence of communications, sensing, and localization, and it will become a main feature in the 6G. In Hexa-X, we will carry out explorative research on disruptive and novel radio technologies. In particular, we will do this in two work packages. First, work package 2 on novel radio access technologies towards 6G. This work package is co-led by TU Dresden and the University of Aarno. And then we have work package 3 on 6G high-resolution localization and sensing. It is led by Chalmers. In addition, we also have participants from Ericsson in Sweden, Ericsson Turkey, Siemens, Nokia Germany, Intel, Orange, Qualcomm, Aarno University, and Telecom Italia. Now we zoom in the scope of 6G radio research in Hexa-X. As shown in this figure, it mainly covers two aspects. First, towards similar infinite capacity and data rate. Second, 6G high-resolution localization and sensing. In Hexa-X, we recognize that when we talk about above 100 GHz or in high frequency in general, it is very important to take hardware capability and availability into account in the design. For example, RF transceiver design, the design of antenna array, etc. So when we talk about higher than 100 gigabit per second achievable rate for access in 6G, it is a must to take in different aspects into account. So in Hexa-X, we will jointly study waveform and modulation, beamforming, radio channel modeling, and distributed large MIMO, together with hardware technologies. The developed results will also provide input for the study of localization and sensing, so that it can embrace the benefit brought by using high frequency, that is bandwidth, and beamforming to achieve centimeter level localization accuracy. So to enable innovative use cases, for example, AR, VR, autonomous robots, security, privacy, industry, etc. In Hexa-X, For the development of 6G radio, we will focus on technology development up to 300 gigahertz, where current semiconductor technology can support. Now we come to technical objectives of Hexa-X respect to novel 6G radio. So in short, what we are going to do is to develop disruptive technique enablers for the efficient use of higher frequency. In more details, first of all, we will study stored multipath channel models based on real-world measurement carried out by Aarno University, and Orange. We will also develop RF transceiver model and antenna array concept to enable joint study of waveform, modulation, and beamforming. As already mentioned in the beginning of this presentation, 6G radio design is all about trade-off between energy efficiency and spectral efficiency. So we come naturally the question that will 5G NR live on? To this end, in Hexa-X, we will not only study legacy waveforms such as DFT pre-coded OFDM, but also other alternatives, for example, normal or general single carrier modulation with frequency domain equalization, constant phase modulation, or analog multi-carrier modulation, or even unconventional methods such as zero crossing modulation with oversampled 1-bit quantization. With respect to distributed large MIMO, in Hexa-X, we will mainly look at the technology development below 100 gigahertz and to achieve extremely high capacity for realistic deployment scenarios. Later in the project, we will also look at the application of such technologies for above 100 gigahertz. In addition, we've also developed low-cost, energy-efficient, and high-performance positioning solutions with unnoticeable delays and strong privacy by utilizing the geometrical nature of propagation environment at millimeter wave and terahertz frequency bands. The target is really to achieve ultra-fast and accurate 6D positioning in all three spatial dimensions, that is latitude, longitude, and altitude, and also all three orientation dimensions that are pitch, rho, and yaw. In Hexa-X, work package 2 and work package 3 are working very closely to develop joint concept and enable the convergence of communications and sensing for 6G. As also mentioned in the previous slide, that from technology development point of view, Hexa-X will mainly focus up to 300 gigahertz. On the other hand, as a flagship project, we will also look into long term. We will extrapolate the results and look into the path to achieve extreme performance, that is 1 terabit per second, including integration aspect of the optical wireless communications, and also for the better commercial use of terahertz in the next 10 or even 20 years. In the end of project, we will develop a 6G radio demo and to demonstrate, evaluate, and compare the performance of developed 6G candidate waveforms in the project with respect to both communications and sensing below and above 100 gigahertz. At the moment, we are working on the first deliverable work package 2 on use cases and gap analysis. It is expected to be published in the beginning of July. Unfortunately, this video was recorded almost 1 month before this workshop. Therefore, I cannot yet share with you our first results. We will come back to you on more details and more technical progress next year. As a last word, we really want to emphasize that 6G radio is not only about terahertz. It's not only about high frequency. It is also about efficient use of lower and middle bands. As 6G flagship project, we look forward to collaborate with other 5G PP projects for a complete 6G radio concept view. If you are interested or have any comments, please contact me, Aarno, and Henk. With that, I wish you a nice day and thank you. And if you have any question, I'm happy to answer.